Good morning, everyone. Long time no see. Доброго ранку. Слава Україні. Come to the stream. I'm gonna wait until you confirm that everything is fine. And let's get started. Everyone, it's been a long break. I'll try to get back. I'm raising the expectations for myself, obviously. And then I can't stream about anything because it's just not good enough. So I decided starting with a bit of a simple stream and then getting back on business on everyday Sunday streaming. So yeah, let me know if you can hear me well. Yay! Hey, hello, Master. Today I'm gonna be replicating. Hello to India too. I'm gonna switch the screen. This is gonna be the website I'm gonna be trying to recreate today. I think it's pretty cool effect. Opinion. And I'd really like to recreate this one. Let's try to do that. Morning, everyone. Morning, everyone. So let's get to business. Yeah, I mean, it's been 100 streams already, so sometimes when I pick a new one, like, okay, something similar already has been created in my stream, so I'm gonna call this one Yuto, because this is gonna be the website by Yuto Takahashi. Unfortunately, I can't link his Twitter because he deleted his Twitter, I think, but I believe it's a freelance developer, so you can hire him to create this effect for yourself. And I really love this effect. Honestly, what? I believe this is some kind of Easter egg on the website. You just scroll too much. Alright. I missed that one. This is actually the first time I see this Easter egg. So there's great attention to detail in those websites. Well, I think this is like a Japanese thing, attention to the detail. So I have a simple PIXI.js boilerplate. I'm gonna copy paste that one and try to run it. Let's see. So code. And then just parcel. Let's see. Yeah, we are missing PIXI.js obviously. And then we also need to, I think this was the old parcel. Bigger. Try to run it again. Oh, it's fine now. Yeah. So this is the boilerplate. It just returns me full screen shader chat, so you can see. I don't know why not three.js. I had a couple of streams in mind, but then eventually I ended up with the PIXI.js. Honestly, this whole streaming started as a just animational streaming, so I never limited myself to three.js, but at some point just 90% of the animations are done with three.js. So I'll create one with the PIXI.js, but then the most important thing that I learned while decompiling all those animations is that the ideas you could use anywhere. Sometimes you could take the idea from the Canvas 2D and use it in the webgl, sometimes the other way around, sometimes from SVG. So in the end, it's just some math and ways to draw curves and graphics on your screen. So from any kind of animation, you can learn anything. And this particular one, I found a nice, neat idea in this animation, which I believe worth telling a story about. So I decided I will replicate this one. Hello to Ethiopia too. Oh, yeah. Yeah, I made a paid course. I'm also thinking about making a really short videos, like 1 minute videos with some life hacks from three.js. Three.js bits, tips and tricks. So if you think it might be something of an interest, just let me know in the chat so I can confirm my idea that it's worth doing. Anyway, so this is the basic template that I'm using here. It has a noise JPEG, just some basic noise pattern. It has a basic setup of the screen camera. So we have the so-called this app. I mean, just an app, PIXI application, which is generally something like a renderer for the three.js, which has some options like the background color, pixel density, and stuff like that. And then it has the app view, which is the same as a renderer DOM element in the three.js. So yeah, this is pretty much it. Pretty short constructor here. And then I also add an object and add a shader. I don't really need this shader. You can find this template in my Patreon, and it's not that big, so you can just type it. It's just from the basic PIXI.js example on their website. And I just added this shader thing. So if I just remove everything, I'll see the red square, which is this element. This is it, adding the element. Let's start with adding an images here, because we will need to create a slider. I'll need to create an image gallery or something. So I already downloaded the image from the original website. It looks somewhat like this. I picked this one because it looks pretty badass. Beautiful, sexy, nice photo, polish. Okay, it's gonna be called image JPEG. Very creative name for the image. And let's start doing. Так, доброго ранку. Let's start doing the stuff. Import image from. How do I call it? How do I call it? Okay, image JPEG. And the first thing I want to do, instead of adding this element, what? Instead of adding just a red square, I want to add the image, obviously, yeah. So in the PIXI, you could create the texture right from the image. You don't have to create the mesh and the... It's not like that's really beneficial, but at least it's simple to add an image to the scene. So right from, and then you just set the URL. The URL is, and then we could just do this app stage, just add, not just add, maybe a child. Yeah, but it wasn't a child. So this is it. We just added an image here. And just to check the aspect ratio of the image, I think I need that. It's a pretty big one. So it's okay. 157. All right, I'm just gonna set it. So first I want to scale the image so to make it smaller. Yeah, of course it's possible. A lot of people are using TypeScript, not only TypeScript, but they are using like React 3 Fiber with a TypeScript, which is using three.js in the end. So yeah, it is totally possible. Of course, there are some edge cases where you need to handle some stuff, because sometimes you need to go deep into the objects, change something in three.js, but it's all fixable. All right. So the first thing I want to do, I want to scale the image so it's not as big, because I need them smaller, obviously. So to do this, I think I can just set the image width. Go with it. Just the image width. Let's say I want to 100, and then the image height is going to be just to preserve the. I mean, you can not preserve it, but it's going to be looking dumb. I'm going to divide it by the aspect. Pretty good so far. Now, first of all, I'm kind of creating the gallery slide by slide. So first one, not slide by slide, but starting with the first slide. And then once I have the first slide, I'm gonna just populate it with a couple of other slides. First, I'm gonna try to create the first slide, try to create all the effects for the slide, and then when I add all the rest, it's gonna look beautiful. Alrighty. So we have the image width and the height, bigger than that. Now I need to center this one. So probably it's best in PIXI.js to add some containers to move the objects around. So this is going to be, I'm going to just call it C container. In the end, we're going to be still writing shaders here and the same math. Actually, all of this is pretty much implementable with three.js, except one thing about this animation, and we're going to see which one. All the rest is pretty much the same you can do in three.js as well, just the other syntax. So instead of adding image directly to the stage, I'm gonna create a couple of layers and groups. First of all, I actually have already like the global container, which is add to the stage. So I'm gonna add all the objects to this global container instead of the app stage. So I'm gonna add my local container because obviously I will have a lot of them because I have a slider. So I will add this one here, and then here I will add to the container. So I'm just adding a kind of a tree of an objects inside my scene now. So I have an image inside this PIXI container, and then I have this PIXI container inside the global PIXI container, which is inside the app stage. Right. This is just as deep as we're gonna go in this stream. Deepest level. Probably, yeah. So we have this, and now with the containers, it's quite easy to handle the to center them. Actually, you can also center the image. I think you can do something like this: anchor, or should I think it's set? Yeah. So now the image is being centered inside its container. So we see the center of the image right here. And now the only thing that's left to do is actually to center the actual container. And the containers, they don't actually have the like the x and y coordinate, but they have the pivot. So the pivot x is going to be this width divided by 2, probably with a minus. Yeah, and the same for the y. Right, and this width and this height is just the the height and the width of the image. All right, so now we have the container. We have an image centered in the container. Getting close. Hello to you guys. Okay, what's next? Next, I want to create a couple of other like layers on top of this image. So we have the image. First of all, you could see that the objects here, and this was kind of a key for me to understand how this whole animation is built, is actually by looking at this particular object. So when I look at it, you could see that the image, well, you could see, well, the ear is almost at the top, and then her neck ends at the bottom of the image. But then if you go to the actual image, you could see that the part that we see there is actually just this. So image is being cropped. And there's a specific reason for that. And this effect is built on top of that reason. Because first, I thought that this whole thing is being distorted with a shader. This is not like that. I mean, this is partly like that. There's a shader distortion, but it's not everything. Then I realized that to create this effect, you actually need an image to be bigger than the actual thing that you see on your screen, because when we distort it, we see more. It's hard to see with this distortion on the website, but when I scroll down, you could actually see that the area on top of the ear is actually much bigger than it used to be. And this is because we could see some part of the image that we wasn't able to see before. And this was actually the key, because sometimes it's kind of hard to decompile some animation. It's not just an easy task sometimes, and you just need to have this kind of gotcha, like that's how he did that. And it's pretty creative way to create this effect. So this effect is created with a mask, or part of this effect is a mask. we need to create a mask on this image, right? So first of all, I'm going to create the mask, and the mask, if you look at the PIXI.js masks, the mask is basically just a field shape mask system. This is the part that I kind of hate about PIXI.js. The docs, it's kind of hard to work with the documentation, and they all have a lot of versions which break each other, but in the end still it's pretty powerful library. So I'm just gonna write the code. You could have used overflow, but then it's gonna be hard to make this shape. Like, how would you make an overflow for this kind of shape? You see it's beautifully distorted, and it's kind of looks like a physical distortion. I mean, I can believe that I'm actually like handling some power on those images and they're being distorted because of my scroll power. Looks natural. This is the word that I've been looking for. All right. Okay. First of all, I need to create the mask. So to create the mask, I create it somewhere here. And create new Pixie graphics. So masks are basically just some objects on the screen. And then need to create mask fill, and the fill mask is something. So mask, we have something fill. I think it's like that. And then you have to set the mask as a mask for the object that I want to mask. If I just set mask as a mask, I probably wouldn't be able to see anything on my screen because, yeah, because the mask is empty. Can't see anything already because mask fill, it's not mask fill probably, it's something else. I think it's begin fill or something like that. Okay, Pixie mask begin fill. Okay, maybe it's mask system, but I was looking just for the mask. Find this. Yes, oh, this is, I shouldn't be looking for the mask, I should be looking for the Pixie graphics because this is the API for the Pixie graphics, right? So it's going to be begin fill. And then I just have to use the same API that is used in the Canvas 2D to draw something on my screen. So I'm just going to do something like mask move to, say, I don't know, 100, 100, then line 2, minus 100. I'm just drawing a square here. And it's gonna be the last one here. And then gonna be mask and fill. And this should be it. Still don't see anything on my screen because mask line 2. Scale of undefined. Oh, because I'm still using some old quad references here. Right, it's all fine now, so I can add the mask to the container. Child mask. Yeah, now I can see the mask, and probably I'll do something like this, like let's mask X, because I need the white mask, and the mask X is going to be something like 450, and then the mask Y, let's say 100. I think 200 pixels should be enough to be like the white image, and then I could just replace all the X with an MX, just drawing the signs, and should be it. Yeah. Maybe mask should be a little bit smaller than the image, something like that. Alrighty. Alrighty, or maybe I just make this one 1050 because I want it to be kind of closer to the edge, so we have this feeling of a, I don't know, stripe of an image. That, yeah. Thank you guys. Thank you guys. All right, so now I can set the mask as a mask, and we could see it actually working. So we see the mask on of the image right now. Once we set the mask as a mask, so it's just field graphics objects. Basically, you could do the same with the canvas two-dimensional thing, just setting the masks over there, but it's not going to be as performant as the thing they're going to be using in PIXI. So I would say PIXI is what it says. It's the best two-dimensional drawing engine right now because it just replaces in most cases the Canvas 2D API, but with a more performant way. Obviously because of the webgl. Alright, so now we have the mask. But how do we do this kind of beautiful distortion with an image? This was like the reason I learned that there's a mask, and then the second reason I learned that there's gotta be a bit bezier curves here involved. I'll just reference how did I go about this one. So in the PIXI.js API, in the graphics, there's a line 2. We have a line 2. Yeah, we have a line 2. But then there's a quadratic curve 2. This is what I'm interested in. And this one using the point to which we need to draw the line, and then the control point of the bezier curve, and the control point here curve. This is basically the point which says how much the curve should be distorted. I mean, like in this case, this point on top is the control point of this curve. Or, oh, this is a nice example. So this one is the control point of this curve. So even though I have the beginning and the end in the same points, I could just add another point, which is the control curve, and we're gonna see something cooler than that. So instead of this, let's say line 2, could use the quadratic line, to the same point, but before that, I will need to add another point. And this one's gonna be, which one's gonna be this one? So this point has to be between those 2 points. So first of all, it's going to be mx plus mx divided by 2, which is the same thing in this case. It's going to be mx plus 100. And let's say my plus 102. Let's just say we just moved at this point somewhere. You could see already this distortion. This might be not the best place for the algorithm, but anyway. So maybe mx minus. So now you could see we can make this kind of distortion with a quadratic curve. And obviously you could create this kind of distortion on all sides of the curve. So instead of doing it right here, so we just learned that we add the same value and subtract the same value and we get this beautiful thing. And then we could create quadratic curve 2 right here. So in this case, it's gonna be mx and minus my. And we're going to be seeing something like this. But then I think we need to find the middle point between those 2 points to coordinate this this point. Like, just because probably it's going to be a mx plus 400 or something, minus 400. So it's going to be in the center, and this value depends on probably the width of my mask. So what I want to do now, I want to draw my mask. Instead of drawing it with a move tool and line tool, I'm going to draw it with a quadratic curve tool. And for this, I will need to do a little bit of the math. So I will need to calculate some additional values. So first of all, just going to create an array because this is just, you already understand the concept. We just need to put the right values everywhere. So first of all, we have the mx and my, and I'm going to create the array of the points. So each object is going to be having the like mx, and then y is going to be y. So we're going to start in the left bottom corner. Then I'll need 4 points like this. So the second one is going to be both minus, and then like this, and then without any signs. Now we have the points, and those, it's just the same kind of points which I was moving through. Probably the first thing stays the same, so I still need to move my drawing tool into the exact position that I need, but instead of this, I'm going to do points 0, points 0. We're going to be starting in some point. Yeah, everything disappeared because I wasn't creating the mask now. So now I need to how do I go about this? Now I need to create all the control points. So I obviously can just do the quadratic curve too in the same order that I did here, like from this point to this point to this point to this point. But I want to be able to edit the control points. So for this, I'm going to just create the control points. It's going to be the same kind of an array, but same, but different. So here, because those mx already has the sizing part inside of it, I'll probably need to fix that. So for the first point, I will need to edit the first point coordinates. I mean, here in the control point, because I'm going to be drawing curve from this to this, I will need to get an average of this. So it's going to be, maybe I should make it p. It's shorter. I will need a lot of those now. p0 x plus 0, which is basically 0 at this point, but just to be able to edit the screen, still better to be able to edit those later on. So this is the middle between x coordinates of the first and the second point. And here we need to do the same for the y coordinate. But because the first line is going to be horizontal, and it's horizontal because we are changing the x coordinate here. In the first and the second point, the x coordinate is changed, meaning the line is horizontal. I'll need to distort the y coordinate then. It's going to be the same for the y coordinate. Y plus distortion. Let's say this distortion is something like 100. It's the static value. You're welcome. You're welcome, mates. So we have the distortion. It's just a couple of minutes until we're going to draw something. Now I need to create the same control points for every next point. Just gonna copy paste. It's gonna be easier to edit those. So in the second point, it's gonna be in the first, second and third, like this. But then the distortion should be added to the x coordinate, because this one's going to be the vertical line, because we're going on a square line. So here's going to be distortion. Then the next one is going to be 2, 3, 2, 3. And then the distortion to the y coordinate. This is correct. And then in the last one, the distortion should be added to the x coordinate again. But then it's going to be different kind of distortion, because the aspect ratio is pretty crazy for the lines that we have, for the stripes that we have. So it's really white, but the height is not that big. So we need to account for that aspect ratio inside this distortion. So probably when we are moving the x along the x-axis, gotta be smaller or something. Okay, let's first just draw something. And the last one is gonna be 3, 0. 3, 0, 3, 0. Okay. At least no JavaScript errors. Perfect. Ooh, greetings to Japan too. Actually, decompiling the Japanese website by Yuto Takahashi. Okay. So now we need to draw those curves because we have the control points, we have everything now. Now all that's left to do is to actually draw the curve. Basically, it would be something like quadratic curve 2. Then we're going to use the first control point, which is, let's call it the big C, because we will need a lot of those. It's going to be C0x, C0y. And then the first point we are drawing to is just going to be the point 0x, point 0. I like that numbers are actually aligning here, so we could just this. Basically, instead of drawing straight lines, we are drawing quadratic curves. Right, it's looking kind of crazy. Not quite what I expected to see, to be honest. There's probably an error somewhere, but let's see. Oh yeah, it shouldn't align perfectly because we are already at the point 0 and we should be drawing to the first point. So it's going to be just next point. It's got to be the next point. All right. Well, nothing is okay. We don't have 4, obviously. Well, that's something different at least. Still not what I wanted to see. Something different. Okay, let's make distortion really small just to see how it changes everything. Something wrong with the actual drawing, I think. I think something is wrong over there. Yeah, Nike logo, yeah. Well, at least we drew something. This is actually like 80% of the whole animation is creating this thing. So let's do this. I have this one. Maybe I messed up an order somewhere of the minuses and pluses. Oh, these 2 points are the same. But it should be minus here. Yeah. Thank you. Yeah. So now I think the distortion is correct. I just need to amplify it. Kind of. So there's gotta be a minus somewhere. You could just guess. I guessed right. All right. And then probably the distortion shouldn't be the same on the edges. So if you have some kind of value for the power of distortion, you need to have some kind of coefficient, like 0.2. We should multiply, let's say it's going to be 0 starters. So it's going to be minus, is it this one? No. It's going to be this one and this one. So I need to make it less on the sides. Right. Looking good, looking better at least. Now we are building that shape. It's not over yet. It's not over yet. So now instead of this shape is already looking similar to the shapes that are used here, but not quite. You could see that the like when you scroll, the narrower edge of this plane, it's actually a narrow edge. Like it's not the same width Whereas here, it's the same width for me, the same X and Y coordinate for both of them. And for this, I probably need to account the direction which we are like distorting an object. And to do this, probably let's start with adding the scroll behavior here. I think in one of the previous streams I already added the scroll behavior, and I'm just gonna go to this one. It was a stream about the Lamadon stream slider. It's not much of a code I'm gonna be copy pasting, but just to save some time because it's not really something. So this is the scroll event, and add the scroll. And for this scroll event, I'll need the, because this was the correct magic number for the nice feeling scroll, and I need the scroll target to be 0. And also need scroll to be 0. And also need the current scroll, because I believe this value is going to be just the speed of a scroll. At any moment in time when I scroll, the wheel delta is probably just the speed in which I'm scrolling this whole thing. So in the current scroll, will be some static value which I'm going to be using to animate stuff. So here, what we have, this is it. Yeah, the code. This is just as much as I copy pasted from there. So this scroll, and then let's console log. Yeah, so we have the scroll, it's minus, it's plus now, it's minus, plus. So basically it's working. And then this direction equals to scroll. Okay. And I can just put direction, just see that I'm doing it the right way. Minus, plus. All right, it's working correctly. So now the next thing I want to do, I kind of want to wrap this whole thing so it's going to be updatable. So I'm going to create a couple of images now, so I could see them, or maybe not yet. I think this is the right time. So I'm going to be adding the stuff. I'm going to create the let images equals image, basically the same image. Of them, and then let or maybe this, what's that, slides equals images map, and then image, and then you PIXI right from the image. Maybe I'd better call it an image. All right, so now we have the slides. Lights, an array of 6 sprites. Perfect. Now instead of creating one container and everything in one instance, I'm going to create everything in the loop. And then I kind of want to these slides, but I want to have another array with all the images. Let's call them these options. It's going to be an array where I'm going to be pushing those masks and containers and the stuff. So I'm just going to copy paste everything here. All this stuff goes inside the loop. Inside the loop, I will also need the number, the index of this thing. And I'm going to create the margin. So this, say 300, because the height of this object is 200, so it's going to be 100 pixels between them. And then. So inside this loop, where would I set the coordinate of this thing. I think the pivot could be the answer to that. Yeah, now we have a couple of those slides. Obviously not centered because we're going just into the one direction. Maybe it's better looking to going down. Now we have those objects. Now we can't actually distort them dynamically right now, depending on the scroll, because we're just drawing this thing one time. It's just in the add method. So we need to move this whole mask creation, and I also need to populate the options area here somewhere in the end. This ops push, and that's gonna be the mask. Gonna be just the mask. Container of this whole thing is gonna be just the, what was it, C, and then the image is gonna be, well, an image, right? Just so I have this array somewhere where I can update it later on. So next thing, I want to move the whole mask part. Like, I create the mask, but I want to update it somewhere on the other place. So like update all the things. Not really all the things, just the masks, but still. So here I will need to loop and update all the things actually. Need to loop these options. Each light. And here I need to update the mask. So far the distortion is just the static variable, which I'm not changing, just the 100, which I'm gonna soon replace with an actual scroll, but I just need to check that everything is in place. I need to run this thing inside a loop. Probably some JavaScript. Mask is not defined because mask, yeah, it's not mask now, it's light mask. And then here it's also. So it's working. I think to update things, I will not also need to clear that mask because it works the same way as the canvas 2D. If you need to redraw something, you just need to clear and draw again on top of that. So, but to do that, I think I can set distortion to this scroll. But this scroll it wasn't a big value, or was it? Let's just see. You could see that it works the same way as the canvas 2D, it just draws on top. It's not clear in the mask, which is also kind of weird animation, but I think there's gotta be clear or something. Okay, it's just clear. Oh yeah, right. So now when we scroll in, we actually have this thing. It's not everything, because I think when I'm scrolling the other way around, the control points are moving not to the direction that I expect them to move. When I scroll multiple, really drastic. So somewhere here, when I'm moving them, the ones that I move with the coefficient, things should be the absolute. So they always move in the same direction to the inside. Yeah, right. So now they move into the inside on both sides. Now the one more touch which makes it really beautiful. Oh, Estonian from Australia. Oh, that's a long time. Flash days. Okay, so I could actually already move them even, I think. But let's stay static for now. Let's preserve the movement, like preserve the movement for the last minute. This is not hard to do. And we also need to move the edges. All right. Concentrate, Yuri, concentrate. So no, it's not all the math, but also I want to distort the whole basic object right here. So depending on the direction, and I think I'll need here. So depending on the direction, if distortion is greater than 0, like when we have the positive distortion, I want to move the bottom the x coordinates of the bottom corners to the inside. Do this, it's gonna look something like this probably. It's gonna be P. Which ones? So basically I need to fix on the either the top or either the bottom coordinates. So the bottom coordinates is going to be P2 and P3. It's going to be P2, which I need to fix with something. Let's say plus P2x. It's the same scroll, same distortion. But the distortion has a sign, so I need to make an absolute thing. All right. Y, and then the same goes for 3, but with a different sign. I think let's try this. Let's just try this. I think there gotta be different signs, but let's see. Okay, maybe we should multiply it with, okay, it's already multiplied, so distortion is quite a big thing already. Why don't we see any changes here? Oh yeah, it's the other because of this. So when I'm scrolling down, okay, the other way around. So almost correct. The left. This. Yeah, now it's kind of correct enough. Changing it here. No. Oh, no. Okay, so it's almost correct, but I think it's gotta be the other way around. So it's gonna be plus here and minus here because we need to move in the opposite direction. Yeah, you could see now that we are kind of creating this arc with this distortion, but I think we need to make it smaller. Just a little. Yeah, you could see now that we are creating this stripe, and we need to create this symmetrical thing for the other direction too. Only for the different, it's going to be 0 and what? And 1, yeah, 0 and 1. It's correctly on that angle, it's not correct on the other angle. So probably the other way around. Oh yeah, it's starting to look good, right? So it's time to add the scroll and then the distortion effect to this one. Starting to look nice. It looks a little bit like a hard coding, but then you could see that the effect is really, really cool because without this one, it's just, I mean, also nice, but not cool. But with this, I mean, it's cool now, right? It's quite hard to create this kind of distortion because you're not only distorting the top line, but also the sidelines of the sides of the object. So yeah, you can see it's pretty cool now. Okay, next thing, let's put it into the scroll. So, and then we're gonna add the distortion effect. Maybe, okay, I said that the scroll is gonna be for the last one. At least I'm gonna add this scroll, while I remember that for current scroll, plus equals this row. All right. Just to see that it's working, there'll be some number, which I could change positive. Seems to be working correctly. Whoa, hello to New Jersey. Safe, yep. Not safe as one could be in Ukraine now, but yeah. A lot safer than a month before, I guess. Okay, so the distortion. To create the distortion, we will need some noise texture. I could take the same noise texture that Yuto used. Just go to the network. So let's write some shaders now. It's gonna be a simple shader, but anyway. Okay, this is the texture. Displays PNG. Displays PNG. Right, so we have the displays. Now I want to create the filter for each of those objects. To create the filter, I will need actually a shader. By the way, while I was explaining the bezier curves, I actually had this bookmark for the Dan Schiffman, and I really recommend watching this video. I'm going to attach it in the description below, because I think one of the best explanation how to use them and what those control points are actually meaning, and how you can write your bezier curves. So, but the thing I wanted to look for right now is actually creating filters in the PIXI.js. So here we have they have the basic shader, which could be used here. So I will just copy paste that one. I think I had it here. And copy paste the vertex shader. I'll need the fragment shader as well. Probably need the same one. Right, so we have the shaders. Now I need to apply the filter. To apply the filter is basically shader in PIXI.js. So to initiate the shader, I'll need two shaders. And where do I put them? So let's somewhere where after I created the image, I could create the filter. Let placement filter. There's actually built-in displacement filter, but it's not. It could actually be used here, I believe. But anyway, I'm going to show you how to create the PIXI filter with the shaders. Text fragment. Then I'll need the uniforms too. Vertex fragment and then the uniforms. This is going to be the displacement filter, and then I can attach that displacement filter to the image filters. It's going to be image. It's going to be an array. So image filters, displacement filter. Now I need the actual fragment shader because I don't yet have the fragment shader right here. I mean, I have it, but it's just looking like the vertex shader. So I will not have the attribute. The uniforms could stay the same, the variant the same. I think the UV is filter coord here. So the UV is going to be filter coord. And then color records. Something like this. Uniforms are not defined. I need to put the uniforms, and inside the uniforms I will need to put an image, because I'll need this sampler image here probably. Okay, so let's first things first. I displacement, and how do you call it? UMap. UMap and UDisplacement. And I need to create the uniforms now. Uniforms. Almost in the end. Boom, 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 boom. Uniforms. So inside uniforms, I'll need U power of the distortion, let's say 0 by default. I need to add it here. And then the U displacement. What did I call it? U displacement. This is going to be displacement. What did I call it? Displace. Texture, because this one is a sprite and I need to take the texture of that one. Then I will also need the U map, which is going to be an image texture. Right. What's next? I think I also need the filter matrix, but maybe later on. So yeah, we have the uniforms. Let's see at least something now. This space. Still something is wrong here. So not of type. Vertex fragment. Okay, let's see. Here we have the shaders in place. Dark color, okay. Thank you. Now we have the red, so shader is obviously working, and now I can output UVs. On with the UVs now. I think I had to use the filter matrix here as well as a uniform, so filter matrix is going to be new PIXI matrix, I think. Yeah. Now we have the UVs. Now we can output an image here. But you could already see that UVs are with an offset. It should be the same color. So let's see how to fix that. There'll be some little PIXI magic here. We have a displacement. We also need the U direction. It's going to be like, let's say 1 by default. It's the direction of the distortion of the shader. Okay. So plot, U power. U power 0, yeah. So far, so good. All right. Now I want to output an image. So I have the UMap inside the fragment shader. I don't need the vertex shader. So D, and then UMap UV. So we have something like this, which is pretty weird and not what I wanted to see here. To fix this, we need to fix the matrix of the filter. And this is done in this way. This is actually from the docs. I think it's in some of the streams already did this thing. So this is how you do it. Input, output, and the last object, I don't remember what that, but so here we need to update the uniform filter matrix actually. And we filter manager, and then function called calculate sprite matrix. which we usually use. This will map the filter coordinates to the same coordinates as the texture. So it's going to be used like on top of the texture. This is what I'm trying to achieve here. So output matrix and sprite. And the sprite, the output matrix is going to be uniform filter matrix. So and the output thing is going to be well, an image. I think just an image in my case. All right, it's broken now because filter manager is not a function. Filter manager. Oh yeah, because it should be calculate sprite matrix here. Well, now something is broken, but I think it's got to be another line. It's going to be apply this filter. This is a bit of a like a black box magic to me because I don't believe I fully understand what is happening here and why we need this specifically. So here we're running the same number of variables in this filter manager to apply this filter. And well, it works. Okay, so now I want to output the displacement map here. Yeah, it's right there. So now in depending on the direction of the scroll, and I could set those directions because I have the displacement filter here. But I could put I don't need displacement. I could put the uniforms right here. So here, when I'm updating this stuff, I'm gonna do slide uniform u dir equals sign of the distortion. Right. It's gonna be either -1 or 1. And then u power is gonna be, well, I think just distortion multiplied with something small, because it's gotta be, make it this. Doesn't change anything so far, but still. And then here, I'm gonna break this one down. Displacement is going to be u displacement uv. Now I want to use this displacement map to distort an image here. So for this, I'm going to create uvx, uvy. I only need the vertical axis, so only will be distorting this one, and I'm going to be distorting this one with the disp r, which is the noise value from the texture, multiplied with u direction and probably some small value and u power. Yeah, and probably some other small value. So let's see. Kind of working. When I scroll that direction, I see this. When I scroll to the bottom, we move in the same way. For some reason, this u power, because this one, it's double sign here. So I just need to make an absolute value. It's -1 getting me 0. Yeah, so now it's a different angle. It's probably too much of a distortion. Too little. Well, kind of. So far so good. So now I could add the scroll and see how it looks with the scroll. How it looks with the scroll. So when we're updating all the things, we could also calculate the actual position of each of the element. And to do this, we change. So update all things. We have the container here. So slide container position y gonna be equal. Could use the index of this element here. We could just use position from here. This bar means the red channel from the black and white texture. So basically we are taking the noise value from the texture in this way, but as a float number, not as a couple dimensional vector. So position is going to be just the index here. And when we update stuff, I'm going to, what is going to be? It's going to be this. It's going to be slide position multiplied with this margin plus this current scroll. Something like this. Let's see. Yeah. Is it? I mean, I can scroll, but the margin is too big somehow. Slide position. For some reason, it's too big. This current scroll. I mean, maybe write this by 2. I don't fully understand why we have such a big margin between them. It's already looking pretty cool, but there's a couple of last touches left here. So I think, oh, because I changed the pivot there, and here I'm changing the actual position. So yeah, I think I just divide it by 4, and I'm gonna even maybe less than that. It's looking pretty cool. So let's make it an infinite slider. It's gonna be the last thing to do here. Still worried about the margin thing. I think I shouldn't set the pivot here. I think this is, yeah, have some kind of conflict here. So I'm just not gonna set this. It's gonna be like that, and then the margin should work correctly. Yeah, so we're getting this. And then the last thing. So I want to create the whole width. I also need the whole width of all these things. So where do I get it? This whole, not the width, but the height. Gonna be called this margin multiplied by this slides length. So basically each slide multiplied, number of slides multiplied by the height of the slide. So this whole height. And here the last touch to make it an infinite slider going to be slide position. This whole width, probably just like that. Yeah, it's almost. I think you need to add this whole width here as well. Yeah, almost. And now I can move this a little bit to the side. I think, should I do this? Just one slide on margin. Yeah, so now it's infinite on one direction, but it's not infinite on the other direction for some reason. Well, like you would add something like this. I believe this is the reason. Maybe I should just take an absolute value and it's gonna be it. But anyway, now it's infinite in both directions. Probably the absolute value of this thing should be taken. But anyway, so now we have this, which is probably the end of it. I didn't miss anything. I'm not sure the direction of the distortion is actually a correct one. And we could also do this, you know, because we put everything in one container. We can do container. And you already have this effect. Looking pretty close. So when I scroll up, it distorts down. And how is it here? Should distort in the other direction. So I just put the minus here. Yeah, I think it's better. There's a better feel. But then I could scroll really hard and get some nice angles. So you don't need this red square. Where was this red thing here? Where did I add this? Oh, I might add it in every single slide now. Alrighty. Well, that's it. Thank you for watching. Hope you like this effect. It's pretty cool, and the thing that I liked in particular about this one is the use of quadratic curves and a bit of a hard coding of the distortion, so you can create a naturally looking distortion. And of course, this one is not possible. I mean, this quadratic curve usage is not really possible in three.js, and you don't really need it. I believe you could create the same effect with distorting it with the shaders, but then again, it's really nice to know all the ways to create the same effect. And it's looking cool. Keita Yamada website. Yeah, sure I can. Well, you can ask me some questions. I'm gonna stay for 2 minutes more online and read the chat. But the main part is finished. I think I decompiled Keita Yamada website at some point. Oh yeah, it's a pretty cool one. But I mean, it's more an artistic effect. It's not that complicated. It's just one shader. And I'm telling you that because I already did that. I already looked into the code. And it's pretty cool. And maybe we could decompile that one too. Because again, I'm just putting too much pressure on myself because I'm saying this one is too easy to make a stream about, but it's not. It's actually a pretty complicated, beautiful, artistic effect, and Keita Yamada is crazy talented guy. But yeah, the idea from this from Yuto Takahashi is actually the use of quadratic curves and then just adding some minor things like distortion, moving corners a bit closer, and then in the end you just get such a crazy cool effect. But it's all so easy, so simple in the core, right? So it could be created with any framework. Then if you know the idea, if you know what you're trying to achieve, like you need to move the corners because you want this effect of the, I don't know, powerful swipe or something, I don't know, when you do this, the energy flow. Pretty cool. And it's also quite performant. You can see the performance here. Let's just measure this one a little bit. Let's see. I mean, 2 milliseconds, and we have like 6 copies of the same object, and pretty good, I think. Also notice that my slider is actually infinitely going, and this is because yeah, now I have inertia which ends. It feels so good actually to scroll this one because I will be uploading the demo on the code drop, so you will be able to interact with it yourself. But it still feels so good to interact with this one. Should create the mobile version as well. Thank you guys. I'm gonna read the chat real fast. Yeah, the difference was in quadratic curve. So instead of quadratic curve, you would need to use shaders and some other method. Yeah, the JavaScript math is pretty hard to not mess up the order of all the corners and things, but then you just need to do this one time. Yeah, thank you guys for fixing my mistakes during the stream. Yeah, Hiro Takahashi is crazy talented guy, so all the credits go to him. I'm gonna switch lastly to me, and thank you guys for supporting me, and thank you everybody for supporting my volunteer initiatives. All those money have been put to use. I can't show you the exact videos, unfortunately, it's not public, but maybe to some of the supporters I will show the video because it's crazy epic how those donations have been put to an actual use. You can actually see how they're working now in Ukraine. So yeah, thank you for supporting Ukraine. Thank you for supporting me. Have a great day. Slava Ukraini. And I'm saying that with an accent now. Okay. By the way, those t-shirts, you can buy my friends throwing them, so 100% of the money go into support Ukraine as well. Have a nice day, everybody. Have a nice Sunday.